Welcome to this tutorials in which we will be looking into the prerequisites needed for implementing deep learning models. Now we are assuming that the viewers of these videos, they actually know one of the programming language. It can be anything. So what do I mean by that is they know the basic programming constructs like looping, conditional statements. Now here in this tutorial what we shall be doing is we shall be looking into the syntax and couple of explanation of basic Python related details, and then we will be looking into NumPy. After that we will be going a bit detail into the PyTorch related works. So we will be implementing CNNs, RNNs and stuff. That is the aim of this full set of tutorials now which will be planned. Now later during the course we will be implementing all the deep generative models using those PyTorch, using those PyTorch libraries. That is the overall aim. So without any further delay, so let us start with the basic programming, which is the standard hello world program. So as you can see here, so we don't normally need to include any kind anybody who is from C or C++, they might be aware of introducing including couple of libraries. We don't need to do any of that. So we can directly start with print. Okay. Now print is a function, so where in which the input that you are giving is inside this double quotes. So whatever you give as an input, the same you will be getting as an output. This is a standard hello world program. Okay. So if you, this is the run, this is, we are using Google Colab. So you can see here if you go ahead and run this play button, so you will be able to see the output here down. Okay. The standard print statement. So now post that. So I hope we learn good things. So we learn efficiently on implementing PyTorch. So then we will look at the variables. So variables, we can think of it like containers. So we can store the data in using those variables. So the basic data types that we can have is integers, floating point, strings and then the boolean. So here all of our examples will be running around the ML related terminologies. So the basic assumption is that you would have taken one of the basic ML course and then you know the terminologies, and then we are just going ahead and showing you how to implement them. Okay, that is the underlying basic ML course. Okay. So now age, now I am just assigning as an integer which is 25, learning rate which is a floating number, so it is 0.001, the course name which is a string, advanced deep learning, and then is GPU available, we are making it as true. So here we can print the contents of the variable, so each of them, so age is the age, learning rate is this, course name and GPU available, and then if you want to know what kind of data type it is, we will be using this type. Okay, print type of this age. So if I run this, we can see here now the age is 25, learning rate whatever value that we have seen. Now here we see that class is int, class is float, class is string, class boolean. So for the variables age, learning rate, course name and is GPU available respectively. See now all of you, I am assuming that are well aware to certain extent the idea of object oriented programming. So when which all these data types are are instance of the classes, and then they will be having their own prescribed methods. Okay, fine. So going ahead of that, some of the basic arithmetic operations, I am declaring variables a and b here. Okay, addition, subtraction, multiplication, division, standard things. Okay. So just for the sake of completeness we are going ahead. So I just want you to point the attention that in division now we have the full division and the integer division. See, the integer division will give you whenever you are dividing, so it will, the integer division will give you the quotient and then this is the remainder. Okay. Now this is the exponentation a to the power of b. So I have 10 to the power of 3, it is 1000, is what can be seen from here. Okay. Now let us look a bit deep into strings. So wherein which indexing is a very interesting idea, and then the same kind of indexing which is there can be extended throughout other data types in advanced data types in Python, like lists, tuples, sets, lists, tuples. Sets does not have indices. Okay. So text, now this is the one. So as we all know, in computers the counting we start from 0. So D will be in the index 0, the first E will be in the index 1, this is of index 2, this is 3, this space is of index 4, now so on and so forth. Okay. So this is what you can see the text, so you can print it, and then if you want to print the first character, so you are accessing via the index 0. So and then for indexing we always use this big brackets. So and then if you want to go ahead and obtain the last character, like we start from this side here with index 0, 1, so on and so forth, the indexing can be in the reverse direction as well. So G will be having the index -1, here N will be having the index -2, so on and so forth. Okay. Now this is text of 0 we will be getting D, and then text of -1 you will be getting G. So that means that you can index it from this side as well as this side. Okay. And then you can perform slicing. So that means that if you want to fetch a certain portion of things, so you can specify that what is the starting point and what is the ending point. Now here we have not specified any starting point, now we have left it. So before the colon that you see we have left it. So that means that the starting position is 0. So that means 0 till 4. That means that you will be getting 0, 1, 2 and 3. Okay. So we will not, it is always end -1, okay, the standard idea. So you will be getting that. So since we have not specified the starting point, so it will be considered as 0. Now here we are specifying the starting point which is 5, and then this position which is reserved for ending point we have not specified that. Now that means that this is from the point from the index 5 till the end. So whatever is supposed to, so till that point you will be able to get it. So that means that let us look into 0, 1, 2, 3, 4 and this is 5. So that means that you will be fetching this learning. So text this is :4 you will be getting deep, and then this 5 till end you will be getting learning. Okay. So and then the length, so the length refers to total number of characters now which is there. So and then these are couple of methods that can be used strings. So this is why we can recall that the string, so the data belongs to string class. So text.lower will convert the text whatever into a lowercase string, text.upper will convert we will be obtaining the uppercase, and then replace, this deep will be replaced by this machine. Important thing to note in these two cases is we will not be going ahead and modifying. So you will be only, we will be not be modifying the original thing, we will be only be getting the modified string as an output. Okay. The original this variable text which is there will be retained as it is. Okay. So now let us run it just to see that. Okay, here. So just to confirm ourselves that I just want to just print it here. So print, so this is text. Okay, just to get that okay, the deep learning which is there as an output. So that means that all these methods which are there will not modify the original content. Okay, so just reinforce this idea. Okay, this is not an in place operation is what I mean by that. Okay, fine. So this is regarding strings. So now let us go into some of the famous data types that are used in Python. The first one is a list. So list is collection of items which are indexed. So that means that each element will be having an index, and then which is mutable, that means that you can modify each of the element. So and then it allows duplicates. Now these are the properties. Now that means that there are certain data types, so which are for example tuple, which we will be seeing next, is immutable, and then the sets which is there, So we cannot have duplicate elements. So depending on the need, now we will be going ahead and accessing the or using the data type which is needed for us. Okay, fine. So numbers, see here please do not confuse that only the data of the similar kind is allowed. No, it is not the case. Now we can have one element which is of integer, another element which is of floating point number, another element which is a string, or a list can be inside a list. So all those combinations are allowed. The only reason why we are taking all the numbers is it is easy to go ahead and perform the execution and show the demo for understanding. Okay, so this is the list, and now we can see here we are just printing the 1. So the first thing that I told you is that now these are indexed. So that means that this is the 0th, this is the 1, this is 2, this is 3. So each of them are indexed like that, and similarly so this 40, now this is -1, -2, -3 and -4. Even that indexing, the indexing from the negative side is also valid. Okay, yeah, as you can see here. So we are first accessing the element. So numbers of 0, so you will be able to access 10, and numbers of -1 you will be able to access -40. Okay, so and then the next element is whether you can add an element. So whenever I mean mutable, what do I mean by mutable is you should be able to modify an existing element or add a new element. So whenever we say add a new element, so in list we have two kinds of adding new elements. Now one is adding at the last, which is append, and adding at any given index, which is insert. Okay, so we will be looking at append now. So now append 50. Now that means that so after this 40 you will be appending 50 at the last. So here the indices of the existing elements will not be modified. So on the contrary, if you insert somewhere in between, so for that you have to specify the index. So after that whatever is there, those indices will be modified. Okay, so append, so after that what is that, and then you have pop. So that means you can remove the element. So whenever you want to remove the element, so that means that you remove the last element, or you remove the element at a given position, or you remove the first occurrence of any element that is there. So here, so we will be just looking at pop. So these additional things that I am giving you, these are the additional facilities that are there. So I want you to explore further, and you should be able to implement those ideas as well. Okay. So numbers.pop, so here the last number which was added 50 now will be removed. Okay. So and then similarly as we did slicing now in the form of strings, now we will be able to do the slicing as well here. Okay, and the length again. So the number of elements which is there. Okay. So as you can see here 50 got added, and after the pop that 50 got removed. Now here you are going till 2, that means you will be getting the element 0 and 1. So that is what you got, and the total length is 4, the number of content. I request you to try one exercise. Now you can put another list here, okay, and try what will be the length. Okay, and always remember, now whenever you are executing the program, now at least you should have a fairly nice grasp of what can be the output. Okay, and then convince yourself that whether your logic holds or not. Now that will be a nice way of going ahead with programming. Okay, fine. This is regarding the lists. So similarly we have tuples and then sets. So please go ahead and explore them. So for most of our implementations we will be working with lists. So that is the reason we just introduced lists. There is one more interesting data type which is dictionary, now which is key value pairs, now which is there in Python. Now people who might have known JavaScript, so they might know this JSON format, JavaScript object notation format which is there, which is almost similar to that. I am using the word similar, it is not the same. So please go ahead and explore those ideas as well. So most of our implementations throughout this course now will be on lists. So we have briefly commented on lists. So moving further, now let us look into the looping, a very important idea. So to give you a small example, See, looping is always, whenever computers are quite famous, and the main reason why they are used, they are good at going ahead with the repetitive tasks. So in repetition there are multiple kinds of repetitions. Now what do I mean by that? Okay, now the question that I am trying to answer is, now when do you stop the iteration? Now one kind of iteration is, I know how many times I have to repeat, and the another kind of repetition which is there is, I do not know how many times I have to repeat, but I know when to stop. Based on a condition I will stop. So just as an anecdotal example which you might like, so one thing is how many times I have to repeat. You can relate this to number of cooker visuals in kitchens that will happen. You should stop at certain time. Okay, first time happened, second time happened, third time happened, at that time you will stop. That's for loop. The other thing is, so frying. So you don't know how many times you have to fry. You will be repeating the same process. Okay, but you know when to stop. So based on certain condition, what vegetable you are frying, now you based on certain inspection you will stop at that point. So these two things you can consider as fair examples of repetitions, just as a matter of joke. Okay, so now here we will be going ahead with for loop. We will not be going ahead with the other looping where in which we know so when to stop. Okay, based on certain condition we will stop. Okay, that is the while looping. So people who are coming from C, so they might know this do while also. Now that is not there here. Okay, so now here we are iterating over these numbers in the list. So now what instructions needs to be repeated? That is the next question to be asked. Okay, I need to repeat, agree. Now what instructions needs to be repeated? Now you have to group those instructions. Now in other programming languages they might use the idea of putting them inside curly braces, but in Python they use the idea of indentation. See, the idea of indentation is you give them a space or a tab. As you can see here, whatever is inside this indented block, now that is considered as a group, and that group will be repeated overall for how many times you are repeating. Okay, so that means that this instruction which is there, this instruction will be repeated. Okay, so you have 2, 4, 6, 8 and 10. So that means that for these values it will be repeated 2, 4, 6, 8, 10. So you can see it here. Okay, so we can run it. So this is the number and its square. This will be repeated for each. First 2 the number will be assigned with 2, and then it will go ahead, then 4. The same setting that is there. Now this is regarding the for loop, and we should be very much aware of that indentation, because grouping of sentences are very much needed. See, for example, I just want to indicate the need of a bit more carefulness. So for example, if I have print high in this case, okay, and run this, see here this high is repeated for each of the iterations. So if you go ahead and push it here, okay, if you go ahead and push it here in this case, and if I run it, you see the difference in the output. Okay, now after this is coming, this is getting only once. So grouping of instructions is very much important. See, since most of you would have learnt one of the training thing. Okay, so for example, if you are running in a batch, so and then you are only going ahead and updating the weight for the last batch, now it will be something like this. Okay, so indentation is pretty much needed, so that for each batch, if it is inside, for each batch it will be updated. So we can recall that specific example here. Okay, so and then going ahead with the conditional statements. we will be looking into if else block. So we can have if else block, so we can remove these two things and then have if else block. So or you can even remove all these things and only have an if block. Okay. The whole idea is, first you have something, you need to go ahead and check for some relational you are going ahead and performing a relational operation. See, the outcome of a relational operation can either be true or false. So here now whatever it is there, if this is true, then it will go inside this block. Okay. Now so now let me remove these two things and then show this. Okay. So this is if it is greater than or equal to 90, so then this will be executed. Okay. Now here 90 is just a placeholder. So if the condition is true, if this condition, whatever condition is being checked, if it is true, then this block of code will be executed. If that is not the case, else this block of code will be executed. So if I run this, I get grade D. Okay. Now because this is 78 and 78 is not greater than or equal to 90. Okay. Now going back to this code, now here that the previous example that we saw was if else block. Now here I have if else block. Okay. So if this condition is true, then you will execute this particular statement. Okay. If this condition is false, then you will go and check the next statement. Okay. This is again another conditional check, another relational operation. Now if this condition is true, then you will go ahead and execute this block. Okay. Again if the second condition which is there in line number 9, if this is false, then you will go and check the condition which is there in this line number 11. Okay. If all these conditions are false, then the default one, which is the else block, will be executed. Okay. If you run this, so then I will get the grade is B. Okay. See, remember this is one block. Okay. So now one of them will be, maybe one of them will be executed. Why I am using maybe is if it is not there and the number is 50, so then none of these output will come. Okay. So that is the idea. So you will check this second condition, okay, only when the first condition yields an outcome of false. You will check this third condition only when the first two condition yields an outcome of false. Okay. So please make a note of this idea. So then we will look at tuples for a very brief time. So this tuple now which is there, now the properties of tuples are, it is collection of non-mutable. Okay. So it is immutable collection of items which are indexed and allow duplicates. So as you can see here, I am repeating these entries, that means that it allows duplicates, and then we declare tuples using this parenthesis. So let's, if you go back and see here, the lists are initialized using these big brackets. Now here these are initialized, the tuple is initialized using the parenthesis, and then even in tuples indexing is done via the big braces only. Okay. Now anywhere, so either it is strings or it is lists or it is tuple, so indexing is always via the big braces. Okay. You can see here 3, 224, 224. Does this number ring a bell? Okay. Now this is the size of your an image in ImageNet data set. Okay. I hope all of you are aware, else we will take an example post sometime. Okay. Now this is the number of channels, this is the height, this is the width. Now as I told you, the examples that we will be taking here are of the nomenclature, preferably of the nomenclature of machine learning. Okay. This is the image shape of 0, so is 3, so that means I am just showing you how to go ahead with indexing. Okay. And repetitions are allowed, you can look at it here. Okay. So and then you can access each one of them via indexing. Okay. I urge all of you to go ahead and try modifying some of the elements inside the tuple, so then convince yourself what happens. Now the another thing what you can try, an additional example that I urge you to try is, now lists are mutable, that means that you can change the contents of the list. Now if I have a tuple inside a list, okay, are the contents of tuple mutable? Okay, just try it out, it will be a nice exercise. So then we will look at the dictionaries. Now as I told, dictionaries are key value pairs. Okay. So dictionaries are preferably useful whenever we want to go ahead and write some configurations for running our models. Okay. So whatever model that we have, if you want to specify the configurations, like what is the model name, so this is the key and this is the value now here, and dictionaries are declared using these curly braces. Okay. So and then the key value pairs are separated, key and values are separated by a colon and key value pairs are separated by comma. Okay. So input dimension is 784, hidden dimension is 128, number of images is 10 and learning rate is 0.001. Does these numbers ring a bell? At least 784 and 10. Okay. This is you are going ahead and declaring a simple MLP in which you are going ahead and taking an MNIST data set and then flattening it out. It has 784 features each image, and then the number of classes is 10, digits 0 to 9. That is what the config is. Here I have just taken an example. So whenever you have learning rate and then what is the device and other things will be added, for the sake of example I have taken this. So we can print this. So and accessing of the values of dictionaries can be done via its keys. Here for if I want to access this model name, this is the key. This MLP, if I want to access this model name is the key. So model config of, again indexing, so we use big brackets. Okay. So if you want to add a new key value pair, for example if you want to add batch size, okay, so model config of batch size, so batch size, so it is not declared, so it will be added. So we can run this and see here learning rate. So you can see here batch size 32, which has been a key value pair that is newly added at the last here. Okay, a key value pair has been added newly here. Okay, this is regarding dictionaries. So now let us look at functions. So functions are a bunch of codes now which are executed when you make a function call, a standard thing. Okay. Now this allows us to have a lot of what do you call, reusability. Okay. So we can write the codes like this and then we can whenever the need is there, we can go ahead and make a function call. I want to take an example of training. See, for example if you are training if you want to train your model for multiple epochs, so you can have a function so to train one epoch and then you can call it multiple times. Okay, so that you can envision it as a function. Okay. Now let us go there after some time. So I just thought I will use a simple example of add numbers. So this is the def, so you are defining, so this is the function definition, you are defining it, the add numbers is the name, any valid variable names you can use. So this a and b are the parameters. Okay. So on result you are just performing some operation, addition is what we have taken here, and you are returning the result. So where you will be returning the results, from where the function call has been made, and then that will be assigned to this answer. Okay. And please note this indentation here. Okay. Now again this bunch of code comes under this. Okay. That is the reason why this indentation is needed. So whenever you are writing in Python, so one important thing that has to be there in the corner of our head is how do we look into the idea of indentation. Okay. Again another example. Now here we are using I have gotten a list of marks, I want to compute the mean. Now what do you mean by that? You go on adding each element, so that means that you want to iterate over the contents of the list and then you want to find the length of the list and divide by it. So you just make a function call, you will come here and these values will be these marks, the list here, and total is currently 0, you iterate over. So each of the time you are updating the total, and then the mean is total divided by the length of the values. Okay. So yeah, this is the idea. So now coming to a very important thing now, which is classes, not the theory classes, the classes which is there in object oriented programming. Okay. So most of the PyTorch implementation, almost 99% of the model definitions that we will be writing now will be using these classes. Okay. So all the models, almost all the models are written using these classes, so we should be able to understand this class. Now this class, this is the keyword, so this is the name of the class, student. This is the constructor, the init method which is there. Okay. So and then the name and marks, this self refers to the instance, so whenever you make a call, so that is being taken care. So these are the attributes, self.name is equal to name and self.marks is equal to marks, these are the attributes, so which are there. And then this is the method, the display, it is just going ahead and printing couple of things. So student 1, you are creating an instance, so whenever you create an instance, the first method that will be called will be the init method. So this name, this Raghava will go to this value name, and this 95 will go to this marks. Okay. The student name is Raghava and then the marks is 95. Okay. So self.name will be Raghava and self.marks will be 95, and then that is what is being displayed here. You are making a call for this method here. Okay. So if you run this, so you will get this. So another example, so a simple model, you have the init, okay, weights and biases. So this is the weight, this is the bias. So and then what will be the forward method? So you get an x, you multiply this weight and this feature x and add the bias term and return y. This is a simple y is equal to wx plus c kind of a equation that is there. So you are creating a model when which weight holds the value of 2 and bias holds the value of 3, and then if x is 5, so you perform 5 into 2 is 10 plus 3 is 13. So whenever you call this forward method which is there, the output that you get is 13. Okay. So this is see here I have not specifically discussed regarding inheritance. Okay. So whenever we go to PyTorch, at that time I will just briefly discuss on it, okay, the idea of inheritance that is needed for us. Now importing libraries, the functionalities that we need may not be there in the Python standard library which is there. So sometimes we want to import libraries. So if the libraries which we need is not there, then we have to install it. Okay. So we are importing this math library. So using this import math, so x, so this is for all the mathematical functions, you can have sine, cosine, so all the standard mathematical functions is here. So math dot square root of x, so 16 square root is 4.0, so 2 to the power of 3 the power math dot pi and all those standard mathematical operations. This code is just to show you that how to import a library. Okay. So these are a couple of standard Python ideas that you should be aware of. So if you are comfortable with these things, so these ideas will be repeated again and again, these constructs will be repeated again and again. So this is a small overview of the basic Python. So in the next tutorial, now we will look into the basics of NumPy. Okay. Thank you. I hope it was helpful. Thank you.